Welcome to the N1IR Electronics blog, video number 9. Bang bang goes the power supply. Well, I was working down in my basement and I have my big Astron supply mounted up pretty high, about 6 feet, and what happened is that Mr. Butterfingers here accidentally dropped his power supply 6 feet down onto concrete. So I got the rare opportunity to put this thing on the bench. It usually doesn't get on the bench that often. I bought this about, I would say 20 years ago at a flea market, and it was in pretty bad shape back then, and wanted to check it out on the bench today and see what happened when we dropped it from a 6-foot height onto concrete. And this is what we got. Pretty rugged little thing. When I bought this, I pretty much had to replace a lot of the chips in here. I had to replace the 723 and some of the pass transistors, which I'm going to get into in a minute, and the crowbar circuit, which I still don't have a SCR for that yet. So I'm going to get into how this all works in a little bit. But anyways, I give this thing a big thumbs up. It withstood 6-foot drop on the concrete. Minimal damage, really only sheet metal bent on this thing. And let's take a look at some of the damage here. So we got a little bit of a bend in the heatsink. Not too bad. And look at the transformer here. It's actually lifted up off the support there, which is fine. I'm actually not going to do anything about it. And here's the other side here. So I bought this thing, I think, for around $10 back about 20 years ago. And a couple things I wanted to go over. If you see these at a flea market and they're dead, you want to take a real close look at them and see if you can actually resurrect them like I did on this one. The big thing is the transformer. You want to make sure the transformer is okay, so you just do a series of resistance measurements with the cover off and measure across the primary. And so you just need a Phillips head screwdriver and a meter to test these things out. And luckily I had one. And let's take a look at this here. So we got our meter hooked up, and this is reading ohms. And let me put this down. And I'm going to measure the primary side on this. And your primary side should be about 1.1 ohms. Shouldn't be a dead short. The secondary is also going to be a low resistance reading. And let me flip this back up. And if your transformer is okay, generally you can resurrect this thing. I've even, on some of them, I've seen the PC boards totally fried and actually replaced the whole PC boards and everything. So they're very serviceable, which gives it another good thumbs up. It's linear. I don't like the switching supplies because the switching supplies have a lot of noise. And this one happens to be a Astron RS-20A 20 amp, which is fine for my station. I run a two 2 meters and an HF radio at the same time, and it provides plenty of current. So I actually had to replace the pass transistors. I've got some NTE ones in there, some cross-referenced transistors, and I replaced the AC cord and the switch. These switches usually go bad, these rocker switches. They'll actually fuse shut, so they'll either be on or off and you can't change it. That's what happened to this switch. I did do a modification right here with these two leads. They come up to an LED, and this monitors the output, and this guy happens to be a neon bulb, so that monitors your input. So at a distance, I can see that I have a good input, 120 volts AC, and a good output of 12 volts. This thing is mounted in a remote location, like I said, so it's I never pulled this thing down until a few days ago. So let we pull off the board here. You always want to make sure the capacitor is discharged. I made sure of that before I started this video. And up in here you might have a couple of problems as well. As you can see, let me take this off. Here's our PC board. And you can see some of the copper is actually off. So what I'm going to do is I'm going to get a connector and solder that in, or a piece of copper and solder it in, and I can bolt it in, and that'll be all set. But usually these caps dry out. You can replace them. That's pretty much a standard cap on the boards. I replaced the 723. That burnt out on this one. I replaced all the caps. This does get warm on the inside, so here's another cap up here. So you want to test out your caps. I just replace them after so many years because they tend to dry out because they're electrolytic. And this is your voltage adjustment. And this is the driver transistor for your pass transistors up in here. These guys do the brunt of the work to regulate. And we have a couple power resistors down in here. So then we get the schematic out and go over how this whole thing works. I'm going to pause this for now and go on to video 2. Hope to see you then.